little crazy and a little pointless that we are doing this. It is used a ton in upper level math classes. We go into it with it pretty in depth in pre-calculus, and then we use it all the time in calculus. So there is a very decent chance that some of you may never use the unit circle again or need it for anything. But there is also a fairly decent chance that you might go into something that's going to require you to have at least pre-calculus or maybe Calc 1. And if that's the case, this will be something that you need to be familiar with. So while we're not going to go into great depth with it, you've at least seen it before, so that if you do have to see it again, it's another class that you have seen it for that. The big topic question that we're going to be looking at is how are triangles, circles, and waves all related together? Okay, so we're going to start by doing just a little bit of review on how to just use regular trig that you learned in Math 2, just regular right triangle trig, because we need a little bit of that to be able to do what we're doing next. So one thing I need you to do first, your calculators are probably way better than they were second period, but in case you do not share a calculator with somebody that corrected this problem during second period, we need to make sure our calculator is in degree mode, and the default for these, if they've been reset, is for them to be in radian. So if you click the mode button right there next to the blue button, so click mode, and down there on the third line, degree should be highlighted. If it is not, if it looks like this and radian is highlighted, then you need to go down there, go over to degree, and hit enter. So make sure you are in degree mode, because if we're doing a problem in degrees, we have to have the calculator in degree mode, or it will not work. It will give us the wrong answer. So in Math 2, you should have learned about how to do regular trig, and you dealt with sine, cosine, and tangent. We don't have to do tangent in this class because the graphs of tangent look crazy and are not all that applicable to real-world situations. So we just have to look at sine and cosine, so those are the only two that I put up here. Whenever you have an angle given to you, you have this blue side right here is the opposite side, the green side is the adjacent, and then always the hypotenuse is across from your right angle. So you may have in Math 2, learn SOHCAHTOA to memorize that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Sometimes I teach my students some old hippie called a high tripping on acid for that one. My husband, for some reason, learned another one, which I don't even know where he learned it from, because we had the same geometry teacher and she did not teach this, but he uses Oscar has a hairy old arm, or whatever other A word, A body part that you want to replace arm with there. I don't know where you got that from, but those are just little things to help us remember which one is which. Really, we're just doing a quick review here because we don't really need to know how to do the Math 2 triangle stuff, other than we need it to be able to connect these ideas. So we're just going to do a couple problems. We may not even do all of these examples that I have here. So if I have this angle right here, and the question has asked me for the length of AB. So AB is this side right here. I'm going to call it X. Okay. The first thing I need to do is decide whether I have opposite, adjacent, or hypotenuse. All right. The hypotenuse is always across from your right angle. So across from this right angle, I've got this side right here. That is my hypotenuse. And then the opposite and adjacent has to do with whichever angle that you're given besides the 90-degree angle. Here, this side is across the triangle from that 35 degrees, so that would be your opposite side. So if we have opposite and hypotenuse, we need to use sine for this problem. So we would say sine of 35 degrees equals, and then we would have to have opposite side on top, which would be x, and adjacent, not adjacent, hypotenuse on the bottom, which is 10. Now, to solve this, we just have to get that x by itself. Right now, it's being divided by 10, so we would need to multiply both sides by 10. So our x would be 10 times sine 35, and we would just type that into the calculator. So 10 sine 35 is going to give us 5.736. Let's round to 3 decimal places there. Do you guys remember doing this in Math 2? Maybe not remember how to do it perfectly, but you at least remember it some. Okay, let's do one more example of this just so we are ready to go. And I think I'm going to skip number 3 there. So let's do the second example right here. This time we've got this angle, and it's asking for DE, which is this side right here. So that side we're looking for, it's across from my right angle, so that is my hypotenuse. And this side right here is the side of this 42-degree angle, so that is adjacent. And so if I have adjacent and hypotenuse, that is cosine. So I'm going to do cosine of 42 degrees is going to equal adjacent over hypotenuse. So the adjacent side is 12. The hypotenuse is x. So this problem is different in a couple ways. Number one, it's cosine instead of sine because we have adjacent and hypotenuse. Number two, it is different for solving because our x is in the bottom of the fraction this time. So I let second period do this one on their own and then realized that that was a mistake because everybody got the wrong answer because they just multiplied both sides by 12, which is not how we do this problem. Since that x is in the bottom, you cannot solve for an equation when that variable is in the bottom. So the first thing you're actually going to do for this is multiply both sides by x. Right there. So I've got x cosine 42 equals 12. And now it looks complicated, but cosine 42 is a number. Right? If I type cosine 42 into the calculator, it is going to give me a number, 0.743144. So really what I have here is 0.743144 times x equals 12. And I just need to divide both sides by that 0.743144. Keep that whole number in your calculator. Bless you. And then we got 12 divided by that answer. It's going to give us 16.148. Or I could have just done it this way. I could have just typed in 12 divided by cosine of 42. And get the same answer. And I'm going to skip 3 because we don't need to spend too much time on this here, which is another type of problem like this. So what we're trying to do today is we're trying to take this idea of triangles and connect it to what's called the unit circle. So the unit circle would be what we get if we graph a circle that has its center at 0, 0, and a radius of 1 unit. So this circle that's graphed here for you has a center at 0, 0, and its radius is 1 unit. And so just because I want us to do a little bit of review right here, can anybody tell me what the equation of that circle is? We did equations of circles at the end of the last unit. What would it be, Isaac? Because if I had that right there, and there's some squares right there, that would have a center at -1, 1. So these numbers right here were like your center points. Anybody else want to try? Okay, it's just going to be an x squared and a y squared. If you wanted to, you could do x minus 0 squared and y minus 0 squared, but it looks a little cleaner if you don't put the zeros there. What's it equal to? What? 1. Technically 1 squared, but 1 squared is just 1 right there. So this would be our equation of our circle, because that formula that we had for the circle is x minus h squared plus y minus k squared equals the radius squared for that. Okay. The reason that I want to remind you of that is because on Desmos, you can graph the unit circle. X squared plus y squared equals 1. And it'll graph that circle for you. Here's where that's going to be useful. I'll go into this more in a minute, but that picture I gave you, the one that says the unit circle at the top, if you hit the wrench right here, you see where it says grid? Where it says grid, you got this option or you got this other one. If you change it, it'll change it to like your unit circle graph there. And then you can see this circle graphed on it for that. So that's coming up, not something you need to know much about right now. That's why we wanted that equation there. All right, so now what we're going to do is we're going to take some triangles and we're going to put them on the circle. Okay, so what I've done is I took that circle that we just saw on the last slide and I've zoomed in a little bit, and I have put a triangle right here. So this triangle right here has that vertex right there on 0, 0. This 0.5, this is a little bit misleading. This 0.5 is not the length of that side. It is just labeling this tick mark right here. So like that right there is 0.5. It's labeling the axis. And the 1 right here that labels that axis kind of got hidden behind the circle. So, you got 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1 for that is what it's doing. So this angle right here is 30 degrees. And it says, what would the coordinates of the blue point on the circle be? So we got this blue point over here, and we're wanting to know the x, y coordinates, right? We could just kind of guess at this, right? So I said that's 0.5, and there's 1, 2, 3, 4, 5 blocks. So each block right here is by like 0.1, and then this goes up by 0.1. So like if we wanted to guess, this is somewhere between 0.8 and 0.9, right? So like if we want just a guess, we could say that maybe it's like 0.85. Might be a little more than that, like 8.6 or 8.7 or something. And then what does it look like the y coordinate of that point is? It looks like it's 0.5. That one I feel a little more confident about. It looks like it is on the point. It might not be. We're going to figure out for sure if it is, but it looks a little better. This one I'm definitely sort of estimating on. So that's my guess for right now. Okay. But what we can do for this is we can sort of pull this triangle off and we can actually find those points. Because this length right here, right, that is your x coordinates, right? Because the distance from 0 over here, that's what your x coordinate would be. And our distance from here to here, that would be our y coordinate. So if I sort of pull this triangle off, and we're just looking at the triangle so we don't get too caught up in everything here, I know this side is x, this side is y. I know this angle right here is 30 degrees. Now, as it is right there, I can't do anything because I don't know the length of any of the sides. But there is one side that we can know the length of, and that is our hypotenuse. Does anybody know what the length of that hypotenuse is? What do you think, Isaac? It will be our c squared. We could do like Pythagorean theorem with this, but that will not necessarily be helpful since we don't have like our x or our y. Like if we found one of them, then we could use that for the other. It's 1. Why is it 1? This is the radius of this circle, right? Goes from the center to the edge of the circle. Very good, Silas. That is a radius right there, so the length of this right here is 1. So we can use trig to find the exact values of this. So if I want to find x, right, if I'm using 30 degrees as my angle, then I would have 1 is my hypotenuse, x is adjacent, and y is opposite. Okay. So let's look for x first. I need to use 1 because that's the only side that I know the actual length of. So I would say that if I've got adjacent and hypotenuse, that's cosine of 30 degrees is going to equal adjacent, which is x, over hypotenuse, which is 1. Which x divided by 1 is just x, right? That doesn't really do anything. Or you can multiply both sides by 1. Either way, basically we're getting cosine of 30 degrees is x. So if I go over here and type that into my calculator, I've got cosine of 30 degrees, and I'm going to get 0.866. So x is 0.866. Now, you're not going to know why, and you're also not going to like it. I'm almost certain you're not going to like it. This is equal to the square root of 3 over 2. If I type this into the calculator, square root of 3 divided by 2, that gives me that same decimal, right? So, second period nearly revolted whenever I told them this, but we need to use square root of 3 over 2. I can explain to you why it needs to be square root of 3 over 2, but the explanation is kind of lengthy, like why it's square root of 3 over 2 and why we can't just use the decimal. For the unit circle, we've got to use exact values, and they are not going to give you the decimal values for that. So we're going to have to use the square root of 3 over 2. So it was an unpopular announcement in second period whenever I did this, but we're going to use that square root of 3 over 2 instead of the decimal for that. So that is what we'll use here. The good news is that the other one is a little bit friendlier because over here, when I want to find y is opposite over hypotenuse. So I will do sine of 30 degrees, and that will equal y over 1. So I just have to type in sine of 30 is going to equal y. And if we do sine of 30 is going to give me 0.5. So, did not mean to do that. So sine of 30 is 0.5, but they are going to want us to use fractions. This fraction is not as upsetting as square root of 3 over 2. It's just 1/2. I think we'll be okay with that. So the coordinates of this point are, oh, I didn't go back far enough. The coordinates of this point right here, our guess was 0.85, 0.5. The actual, the correct one, is going to be square root of 3 over 2, 1/2, which our guess was pretty close, right? Those are the coordinates of that point. It has to do with some rules for like special right triangles, like 30, 60, 90 triangles and 45, 45, 90 triangles. And the explanation for it is going to take longer than we have time for. So I just kind of need you to trust me that it is that. We're going to have to kind of memorize that because we're going to have to memorize things about the unit circle. So just kind of take my word for it. On that. I know that's not. You won't be asked why. You won't be asked why. So they will not ask you why it's square root of 3 over 2, and you won't have to know how to find square root of 3 over 2 on your own. So if you want to come to Smart Breakfast and ask me that question when you in your spare time, if you're just dying to know, I can explain it better. We just don't have time for a better explanation right now, and it would just be like a chasing a rabbit because you don't have to know it to know this. So what we've got to do. So now let's talk about what these represent. Okay. So we want to know, what do these coordinates x and y represent? So let's say I've put a different point on here and I did not give you the angle. So this is still the unit circle, and I've given you a different point, right? So this is just a hypothetical point that we're using here. So this angle right here, I'm just going to call it theta. That's the variable we like to use for angles a lot of times. We have that angle right there is theta. The length of this side right here would be our x coordinate. The length of this side right here would be our y coordinate. It is still true that the hypotenuse right there, is 1 because it's still a radius. So that is 1. So if in a more general sense, we want to kind of do what we just did on that last one for this problem. If I want to find x, then I would need, this is my adjacent side, this is my opposite, this is my hypotenuse. So to find x, I would need to do cosine of whatever that angle is would have to equal adjacent, which is x, over 1. So x is going to equal cosine of theta. And if I wanted to do this in a more general sense for the y, that would be sine of theta would equal y over 1, which means that my y is going to equal sine of that angle. So, what's going to happen for this is on the unit circle, wherever we are at, we are used to thinking like first quadrant sort of stuff. Because when you guys did trig in Math 2, you never dealt with an angle bigger than 90 degrees. Because when we're talking about the triangles, it doesn't make sense to have an angle bigger than 90 degrees. So for what we're doing with the unit circle, we're going to go beyond 90 degrees for these. So wherever we're at on the unit circle, we could be right here, we could be down here, we could be way over here, we could be, anywhere on the unit circle. The x-coordinate of your point on the unit circle is the cosine of whatever angle is made there. And the y-coordinate is the sine of that angle. Now, the unit circle was really, really, really important before you had calculators. Because back long ago, if we wanted, right now, if we want to know what sine of 30 is, we just type in sine of 30, like we did just a second ago. We type in sine of 30. We're asking the calculator, Mr. Calculator, what is sine of 30? We hit enter. He says 0.5. Right? He just knows, that. We don't necessarily know that, but the calculator does. And the calculator is even better than the unit circle because we can ask the calculator, what is cosine of negative 134? And it will tell us what cosine of negative 134 is. So this calculator is very helpful and takes away one of the uses of the unit circle. Now, the reason that we still have to learn the unit circle is because it's what's going to connect our triangles to our wavy graphs here. So, and for you guys, you can use your calculator on the whole entire exam. So you guys don't have to know necessarily, you kind of have to know the unit circle values. I'll show you like some sort of ways around it, but I am going to have you guys memorize this. Whenever we get to, when you get to like pre-calculus or calculus, if you were to take those, if you take them here, they have non-calculator sections of the test, and we have to learn it by hand. I would imagine a lot of college teachers are going to teach it that way as well, where you can't just use your calculator on everything, but it really depends on who you have. So, you guys have a little tiny, you have the first quadrant right here, but if you would like, you have that bigger unit circle. So you have this right here. And if you would rather put your information, this is just like the first quadrant of this, so if you'd rather put your information on here, you may do that there. The unit circle is so beautiful, so cool. I'm not a huge tattoo fan because I am afraid of the permanence of those things, that I might get sick of something, but if I was ever going to get a math tattoo, I think I might get the unit circle. It'd be pretty cool. Be a dedicated math teacher if I had that. So I might need to think about that, but probably not going to. But if I did, it would be the unit circle. I think is what I would get. That or the integral symbol. I like that one too. It's pretty. All right, so let's fill up the first quadrant. Okay, so on this circle, we're putting a lot of stuff together that we've done. So on this circle, right here is 0 degrees. How many degrees do I have right here? That'll be 90. That's 90 degrees. So this right here looks like it splits that in half. So what do you guys think that's going to be? 45. This one right here is 45. Okay. Then this one right here is 30 degrees. And this right here is 60 degrees. just to show you a little something that can help you on this, because we're going to have this memorized. I am going to make you memorize it, and I'm not going to let you use a note card, but I will let you use Desmos. Desmos will, on Desmos, I showed you a little bit earlier. If I go over here to Desmos, and I click right here, and change that to a unit circle, it doesn't mark everything, but it marks some of these. Right now, it's in radian mode. If I click over here to degree, it'll give you most of your degrees, right? So you can kind of copy that from there. So I've got, 0, 30, 60, 90. You kind of have to put together that that's halfway between, and that's 45, that this is 225 there. So that can help you a little bit. Now, I also have to know radians. Okay, radians seem very crazy on this, but the Desmos will help us some on that. So, good news about 0 degrees is that it is also 0 degrees is also 0 radians. Okay, 30 degrees is pi over 6 radians. 45 degrees is pi over 4 radians. 60 degrees is pi over 3 radians. And then 90 degrees is pi over 2 radians. We could go through and convert like you guys were doing on the quiz. We could take 30 degrees and multiply it by pi over 180 and convert. It'd give us pi over 6 for that. So those are our radians there. We have to know both of them. Now, the good news again is you don't have to memorize too many of them, because Desmos will give you most of them, right? So Desmos, if you click over here, if you click over here on Desmos right now, it's in degrees. I got 0s, 30, 60, 90, 120, 150, 180. It's giving me my degrees. If I hit the wrench and I change it down here back to radians, it will give me those in radians. The only one it doesn't give you is pi over 4 right here. It leaves that off. So those, like these 4 pieces right here, this, and this are going to be the only ones that we really have to memorize, because Desmos can give us the rest. So it sounds terrible, but Desmos will give you most of them. Okay, so let me go back over here. All right, so on the unit circle, the radius is 1. So this point right here would be 1, 0. And then again, the radius right here is 1. So that vertical point right there, that is 0, 1. Okay, so that problem that we did where we put the triangle in there and we had the 30-degree angle, when we found the coordinates of that point right there, we got square root of 3 over 2 and 1/2 for that. And then for my 60 degrees, because if a triangle has like one angle is 30 degrees, the other one is going to be 60 degrees, it's flipped. This is 1/2 and this is square root of 3 over 2. And then this one right here is going to be square root of 2 over 2 and square root of 2 over 2. So, just one more thing before it is time to go. So, like, let me just show you, like, why this was important back before calculators. Imagine that you had a triangle right here where this is 30 degrees and this is 10, and you need to know what, actually, let me do that the other way. Okay, this is X right here, and this is 10. So if you don't know what, if you don't have a calculator, you will set that up. Sine of 30 degrees is X over 10. And you'd multiply both sides by 10, and you would get X equals 10 sine 30. But if you don't have a calculator, you don't know what sine of 30 is. But with the unit circle, the X coordinate is your cosine of that angle, and your Y coordinate is the sine of that angle. So if I have the unit circle, I can go to 30 degrees. I can say 30 degrees, I'm looking at the Y coordinate, sine of 30 degrees is 1/2. So X would equal 10 times 1/2, which would give me 5 for that. So that's one of the uses without calculators. Now, there's another reason, because I know that the argument, like you won't always have a calculator, is a terrible argument to make these days. All right, so, are you good and confused now? Good and confused? All right, we're going to try to put this all together tomorrow, and hopefully get out of here understanding a little bit about it, and even if we don't understand it, maybe we'll be able to use it and answer the questions. Okay. So don't lose that unit circle paper I gave you too. We're going to make sure we got that filled in tomorrow.